So up here we've got an example of a rate law, which is it's rate set equal to K times the concentration of A raised to a power of X times the concentration of B raised to the power of Y. So in this rate law, and this is how any rate law is going to look, rate equals K times the concentration of the reactants. You'll notice I've got dot, dot, dot here, because if there were 3 reactants, you would have put C, D, and so on until you've used up all the relevant reactants in this rate law. So the rate on the left is simply the rate of the reaction, and in most cases, we measure that in molarity or molar per second, which can also be written as molarity inverse seconds. So the most common way of notating the rate of a reaction. And you could think of that as maybe products being formed at a rate of 2 molar per second, or reactants being consumed at a rate of something molars per second. So the rate is going to be equal to K, which is the rate constant. And despite the name, this constant is not constant. It's different for each reactant in any reaction at any given temperature. So this can change with reactions, and importantly, it changes with temperature. Because if you increase the temperature of a reaction, you're going to change its rate. So we've already said that the brackets A and the bracket B are the reactant concentrations, and this is measured in molar or molarity, which is moles per liter. And it's these numbers up top that are going to be the most important as we progress through the entire unit, but these are the reaction orders. The reaction orders are the powers that these concentrations are raised to. And in this class, you should only see 0 order, 1st order, or 2nd order on your reaction orders.